Hey everyone, welcome back to our TxePrep calculus video, and in this video we're going to talk about the product rule for derivatives. So let's say that I want to find the derivative of a function like sine of x times e to the power of x, and obviously with the rules that we've just covered, we don't really have a formula for finding the derivative of sine of x times e to the x, but you may be tempted to think that this would be the same thing as the derivative of sine of x, which is cosine of x, times the derivative of e to the x, which is basically just e to the x. But that's where you're wrong. It's actually quite different because of the product rule. And the product rule, this is not equal, and the product rule states that the derivative of f of x times g of x is equal to f prime of x times g of x plus g prime of x times f of x. And we'll try proving that using the limit definition of a derivative. So when we set everything up, this is going to be the limit as h approaches 0 of f of x plus h times g of x plus h. And the reason we're doing two functions is obviously because we're trying to take the derivative of two functions together. And after that, what we're going to do is minus f of x g of x, which is just the standard definition of the derivative, finding the derivative using the limit. And this doesn't really help us in any way. We can't really simplify this using any, especially well-known techniques. But luckily we can do some algebraic manipulation and try adding some things to the numerator and then subtracting it back out so that it makes it easy to factor. So what we can write this as is the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x plus h times g of x. And then obviously, since we're subtracting something that's not part of this function, we need to add it back on just so that we make sure that we're basically adding 0 and keeping the function the same. So what we're going to do is add f of x plus h times g of x and then minus f of x g of x. And all of this is divided by h. And now as you see here, this makes it really easy to factor, which is exactly what I'm going to do. So I'm going to factor out the left and the right. So I'm going to factor out f of x plus h from both of these two terms over here. So it's going to give me f of x plus h times g of x plus h minus g of x plus, and I'm going to factor g of x from that side over there, g of x times f of x plus h minus f of x. And obviously all of this is going to be divided by h. And now what I can do is actually split these two terms apart. What I can do is like this. I can just split the fractions apart and make it look like this. And now I can split the limits apart. And that you'll see why that's going to help us. So I can rewrite this as a limit as h approaches 0 of f of x plus h times g of x plus h minus g of x all over h, plus the limit as h approaches 0 of g of x times f of x plus h minus f of x divided by h. And since these two are being multiplied together, we can use limit rules once again and split these two limits apart. So this leaves me with the limit as h approaches 0 of f of x plus h times the limit as h approaches 0 of g of x plus h minus g of x divided by h. And you may notice something really important over here. This is literally just the definition of a derivative. We can rewrite this as g prime of x, or basically the derivative of g of x. So I can get rid of all this limit stuff and just rewrite this as g prime of x plus, and then we continue on over here, the limit as h approaches 0 of g of x times this function over times this thing over here. And this is exactly the same logic as before. This is the definition of the derivative. So we can just rewrite this as f prime of x. And now we're just ready to simplify these limits over here. So the limit as h approaches 0, f of x plus h just approaches f of x. So we can just rewrite this as f of x times g prime of x. And the limit as h approaches 0, g of x is simply just g of x times f prime of x. And there we have it. That is the definition that is basically the product rule using the definition of a derivative for when you're multiplying two different functions together. And now let's try applying it to the example of the derivative of sine of x to the times e to the power of x. So now we're taking the derivative of sine of x times e to the x, and the first thing to remember that this is not equal to the derivative. This is not equal to cosine of x times e to the x. Instead, we see that two functions are being multiplied together, so we must use the product rule. And as you remember, the product rule states that the derivative of f of x times g of x is simply just f prime of x times g of x plus g prime of x times f of x. And obviously you can rewrite this in whatever order because addition is commutative. So you can just rewrite this as g prime of x times f of x plus f prime of x times g of x. So this is going to be the same thing as the derivative of g of x times f of x. And that's exactly what we have here. All we need to do is just plug this in. So that means that the derivative of sine of x times e to the x must be the derivative of sine of x, which is basically f of x, so we're taking f prime, times the derivative of g of x, just g of x on its own, so basically e to the x, plus, and now you see there's a g prime over here, which must mean the derivative of g of x, which is e to the x, and the derivative of e to the x is just e to the x, and times the multiplied by f of x, and f of x is simply just sine of x. And that is equal to the derivative of sine of x times e to the x. So we just need to simplify this out over here. And that's not too hard because we have handy formulas that we have memorized already. So the derivative of sine of x is simply just cosine of x times e to the x, which is over here. And the derivative of e to the x is simply just e to the x times sine of x, which is as we have here, meaning that the derivative of sine of x times e to the x is actually equal to cosine of x times e to the x plus e to the x times sine of x. So I hope you guys understood how we can apply the product rule to help us find the derivative of functions that